Good morning to all. In the CET, there is a next topic is that ejectors. So, what is the function of ejector? What are the ejected, and why it is required? Okay. So let's see that ejector is also known as a jet pump. So ejectors or a jet pumps both are same. So ejectors and the jet pumps are devices which employ the momentum and kinetic energy of high velocity stream to entrain and uh, compress a second gas or a vapor stream. Ejector or jet pumps are devices which employ the momentum and kinetic energy at high velocity streams uh, to entrain and compress a second gas or a vapor stream. મતલબમાં શોર્ટ ટર્મ્સની અંદર જોઈએ તો કે જે ગેસ છે બરાબર, ગેસને કમ્પ્રેસ કરી અને શું કરે છે, ફ્લુઇડ બહાર નીકળે, કમ્પ્રેસ કરવાનું કામ કરે છે, પ્લસ એની વેલોસિટી શું કરવાનું, વધારવાનું કામ કરે છે. ઓકે, સો the steam jet ejector is given below. So steam is entered at the left hand side, okay, where the nozzle is very short, and then this one is a nozzle, okay, and gas inlet is the bottom of the part, and this one is a diffuser section. Diffuser section, that means compressed air is diffused and increase the velocity, and this one is a maximum mixing space. So the main role of the ejector is that steam is compressed and inlet the velocity of the fluid. Okay, so the velo which is employed for what purpose, momentum and kinetic energy of a high velocity stream to entrain and compress a second gas or vapor stream. Okay, वेपर इसको गैस में और या तो फिर वेपर स्टीम में कंप्रेस करना है. ठीक है. Steam jet ejectors are used for pumping large volume of vapor and gas at a lower pressure. Okay, so this one is most part. It is main function is that it is operated at lower pressure and converted into the high pressures. So steam ejector are used for the large volume and vapor and gas at a low pressure. See in figure. And the ejector is considering consistence of following part. First, nozzle for accelerating the primary fluid. Okay, nozzle is used here. Then fluid suctions for acceleration the secondary fluid before it's entering. Steam, gas, steam and gas. Okay, mixing sections where the mixing space where the A and B are the mixed. In the mixing section where the secondary fluid is further accelerate and primary fluid is uh, decelerated, that means at over here. At that part, okay, જ્યાંથી ફર્સ્ટલી શું થશે, સ્ટીમ અહીંયાથી એન્ટર થશે, બીજું જે ગેસ ઇનલેટ થશે એ ક્યાંથી થશે, અહીંયાથી. બરાબર, તો હવે બંને અહીંયા શું થશે, આ જે સેક્શન છે મિક્સિંગ સ્પેસની અંદર ત્યાં શું થશે, મિક્સ થશે. ઓકે, ડિફ્યુઝર સેક્શન ફોર decelerating the combined steam of primary and secondary fluids with consequent increase in pressure. બંને શું કરે છે, એક્ઝિટ થાય છે પ્રાઇમરી અને સેકન્ડરી વિથ મિક્સિંગ એટ ધ કોન્સિક્વન્ટ ઇન્ક્રીઝ ઇન પ્રેશરને ઇન્ક્રીઝ કરીને. Steam, which is primary fluid, it is first expanded by passing through the nozzle. Steam primary fluid, it is first expanded by passing through a nozzle where it attains supersonic velocity. Where it is attains supersonic velocity. જે પ્રાઇમરી ફ્લુઇડ છે એ શું થાય છે, ફર્સ્ટ એક્સપાન્ડ થાય છે, બરાબર, જે નોઝલમાંથી આવે અને શું થાય, એક્સપાન્ડ, શેમાંથી, નોઝલમાંથી. એન્ડ ક્યાં મળે છે, તો કે ડ્યુ ટુ ધ સુપરસોનિક વેલોસિટી. Due to the high velocity of the steam, due to the high velocity of the steam entering the mixing space, બંને ક્યાં એન્ટર થાય છે વેલોસિટીના લીધે, મિક્સિંગ સ્પેસ, where it having a low pressure region is created, then it result in the steam's transfer of its momentum to the gas or vapor, that is secondary fluid, and entering through the gas inlet. જે ગેસ ઇનલેટ દ્વારા શું થશે, એન્ટર થશે અને ક્યાં મિક્સઅપ થશે, this one is in the diffuser. So it is the vapor or gas is entering through the gas inlet in the diffuser section, and the mixed steam is decelerated and it is get compressed. બરાબર, ત્યાં શું થાય છે, એક્સેલરેશન ઓછું થઈ જાય છે અને કમ્પ્રેસ થાય છે. સો ધ વર્ક ઓફ કમ્પ્રેશન being derived at the expense of its kinetic energy. The compressed gas leaving the ejector is discharged directly to the atmosphere. Compressed gas જે સામા રિમૂવ કરવામાં આવે છે ડાયરેક્ટલી એટમોસ્ફિયરમાં, અથવા તો ઇટ કેન બી સેન્ડ ઇટ ટુ ધ વોટર કુલર કન્ડેન્સર. ઓકે, જે ઇજેક્ટરમાંથી નીકળતું જે લિક્વિડ છે, બરાબર, એને ડાયરેક્ટલી શેમાં જવા દેવામાં આવે છે, આ તો ફિર એટમોસ્ફિયરમાં અથવા તો વોટર કુલ કન્ડેન્સરની અંદર એન્ટર કરવામાં આવે છે. Then later option is employed in a multi-stage ejector is to reduce the quantity of steam handled in the successive stages. અથવા તો તમે બીજો ઓપ્શન એ પણ છે કે તમે શું કરી શકો, મલ્ટી સ્ટેજ ઇજેક્ટર તમે બનાવી શકો છો. શાના માટે, ટુ રિડ્યુસ ક્વોન્ટિટી ઓફ સ્ટીમ. And exhaustive thermodynamic analysis of ejector performance requires application of equation of continuity, momentum and energy to various component part, and the overall efficiency of the ejector is the ratio of work of isentropic compression to the secondary fluid from the suction to the discharge pressure. The overall efficiency ejector, it is the ratio of isentropic compression, જે convert section છે ત્યાં. So it is the ratio of isentropic compression of the secondary fluid, work of isentropic compression of the secondary fluid from the suction to the discharge pressure, and divided by the work of isentropic expansion of the primary fluid from its initial to discharge pressure, Now, the throttling process, or it can be said that it is known as Joule-Thomson's expansion. Throttling process છે એ શું છે, Joule-Thomson's expansion છે. Okay, so let's see. A throttling process, also known as a Joule-Thomson's expansion, it is a steady flow process across restrictions which result in reduction in pressure for the fluid. ધ મેઇન જે યુઝ છે બરાબર આપણે પ્રિન્સિપલ કહી શકીએ છીએ. It is an steady state, steady flow process across where the restrictions across a restriction which result into reducing pressure for the fluid. The flow through the partially open valve or a porous plug is a typical example of throttling process. The flow through the partially open valve કે જ્યાં શું થતું હશે થોડો વાલ ઓપન કરીએ તો ત્યાં શું થશે પ્રેશર જે છે એ શું થાય છે રિડ્યુસ થાય છે. એટલે કે પોરસ પ્લગ અથવા તો અડધો ઓપન કરેલો પ્લગ છે વાલ્વ છે બરાબર એ is an example of throttling process. The throttling process may be treated as an adiabatic operation because of the expansions take place in every short time within a very small region. So the heat exchange between system and surrounding is negligible. So the heat exchange between system and surrounding here is negligible. And the no mechanism present for the extracting work. So the process is highly irreversible. This process is highly irreversible. Okay, because એકવાર in the flow process if we tap is or the valve is half open then the pressure is maximum. At that point it should be not possible to reverse operation because already the pressure in the pipe, so it is not possible to back reversible operations. So the kinetic and potential energy change are negligible. Kinetic energy is also not possible and potential energy which is also not possible. So the equation 5.10 to describe the throttling process, that means shaft work and heat generation is 0. So dq is 0, dw is 0. So equation reduced dh is also 0. So Joule-Thomson's expansion is an isenthalpic process and the temperature of the gas change as a result of this expansion, and the change in the temperature result from the throttling process is known as a Joule-Thomson's coefficient. And Joule-Thomson's coefficient mu, which is defined as a mu del T by del P at H. During the total expansion process, delta P is negative. The value of change of pressure is negative, outlet to inlet. Therefore, positive value of Joule-Thomson coefficient means that delta T is negative and the gas cools on the throttling. मतलब કે Joule-Thomson coefficient માટે હવે જો વેલ્યુ પોઝિટિવ બનાવ્યું હોય તો ટેમ્પરેચર શુડ બી માઇનસ, એટલે કે ત્યાં તો જ Joule-Thomson coefficient પોઝિટિવ થાય, માઇનસ માઇનસ કેન્સલ થઈ. અને એના માટે શું થતું હોય છે કે જ્યાં થ્રોટલિંગ પ્રોસેસ થતી હોય છે ત્યાં ઇટ્સ રિક્વાયર્ડ ધ કુલ ગેસ. ઓન અધર હેન્ડ નેગેટિવ Joule-Thomson coefficient means that throttling result in increase in temperature. થ્રોટલિંગ પ્રોસેસની અંદર મતલબ એવો થાય છે કે ત્યાં ટેમ્પરેચર શું થાય છે વધે છે. So the Joule-Thomson coefficient of a gas can be determined by using the pressure volume temperature relationship, and this one is discussed in the next chapter. If sufficient here to note that any given pressure the Joule-Thomson coefficient is positive only within a temperature range, that is between the upper and lower inversion temperature. Only within this temperature a gas cools on throttling. Gas is cools on the throttling. For a perfect gas, enthalpy being a function of temperature alone, enthalpy is a function of enthalpy on temperature only, and the throttling, which is essentially constant enthalpy process, produce no temperature changes. and Joule-Thomson coefficient of ideally is 0. Okay, where constant enthalpy process it is should be no change. And for real gases above certain pressure, the throttling process always result in cooling. For nitrogen, in this process found to be about 375 bar. Okay,